All right. Now let's talk about randomization. How we can generate random stimulus. To generate different kinds of scenarios, we can think of generating different flavors of the packets. This is what we discussed. So you can think of different flavors like write packet, read packet, and odd ports. So the write happens only on odd ports, the read happens only on odd ports, or even write, even read, or completely random. That's how you can think of creating different flavors of the packets and verifying the memory or DUT. So what we do in SystemVerilog, while creating the class, this is what we discussed in SystemVerilog. We are going to define class. Class will have members and methods. All right. Look at the members. Members are nothing but variables. And we define all the variables as rand or randc. And for every variable, we define constraint. Also, what we do, we define the class and then we extend the class into different classes like extended classes. And for each extended class, we redefine the constraint. That's how we would be able to define different flavors of the packets. We will discuss all these things in detail during the language course. This is how you can visualize how different flavors of the packets will be generated. Different write packets, different read packets, write packets for odd ports, write packets for even ports, read packet for odd ports, read packet for even ports. And for every packet, we generate functional coverage. So eventually we are going to look at like whether we have generated all possible packets and how we verified the DUT. That's what we are going to look at. All right. Let's go back to the SOC, Maven SOC. This is how basically we connect the test case with the DUT, and the SOC has got all the interfaces: GPIO, AXI, AHB, PIO, AHB, and SPI. So to generate random values, obviously we need to define all these packets: AHB packet, AXI packet, GPIO, PIO, SPI, and register packet. And if you look at, we define all the members within the class as random. That's how we are going to generate random packets. So there will be different random AHB packets, different random AXI packets, different random GPIO packets, different random PIO packets. That's how we would be generating different kinds of random packets. And for each packet, we have to generate functional coverage, and based on the coverage only, we would be able to sign up the verification. So how we do that? Okay, look at this example. This is a router. The router has one input channel and multiple output channel. Whatever the packet you drive through input channel, eventually the packet will be sent to one of the output channel based on the address. That's how the router works. And this is how the test bench architecture would look like. For every interface, there will be driver and monitor, and you make all the connections in the test bench. Fine. We are discussing about coverage. So to generate coverage, we need to define the coverage goal. This is what we discussed as part of verification methodology module. So here I can think of generating different flavors of the packets like small packet, medium packet, big packet, or error packet. And I want all the packets to go through all the channels. So there are three channels: channel 0, channel 1, and channel 2. These are all output channels. So for me, if all these packets go through all the output channels, then I can confirm that the router works fine. That's what this combination means. 4 into 3, there are 12 combinations. If I would be able to generate coverage for all these combinations, then I can confirm that the design works fine for all possible scenarios. That's called coverage goal, and based on the combinations, we have to define the coverage model. And based on the coverage model only, we are going to run the random simulation. This is what we discussed, constraint-random coverage-driven verification. The complete simulation is going to be based on coverage value. Now, the important thing is, in SystemVerilog, we have to define the coverage model. Without coverage model, you won't be able to generate coverage value. So in coverage model, what you do is you try to generate coverage value for each variable. You have variable like address, read address, or output data. Then for the address, how many bins you want to create. If the address is huge, billions of possible values, then you don't want to cover each and every value because that will kill your simulation time. Then you can think of defining possible bins, maybe based on your interest. That's how you define coverage model. So if you look at the coverage model, it will have cover points, and the cover points will be defined for every variable, and every cover point will have possible pins. And finally, you can think of crossing the cover points. We discussed about router, right? So the router needs all possible packets like small packet, big packet, medium packet, or corrupt packet. And then all the packets should go through all the channels. So the channels will be like channel 0, channel 1, and channel 2. So in this case, all these things are cover points. All the packets and all the channels are cover points. And for each cover point, you can think of defining bins. And that's what you do in SystemVerilog. Don't worry about the syntax. We are going to discuss in detail during SystemVerilog course.